So good morning, everybody. Thank you so much for joining this morning. It's really a privilege to be able to speak to you, and thank you to the NSTF for organizing this forum. I really enjoyed yesterday, and I enjoyed Yanci's recap on the important strands from yesterday. So I'm going to share a screen, and I really want to encourage you to ask questions and to give lots of feedback, because I've got an hour slot. And if you listen to me for an hour, you're all going to be asleep before tea time. So please, quite a good way to ask questions is using the chat. And as the question comes to mind, just pop it into the chat. And then I'll ask Yancy and Vilna if you can just help. It's difficult for me to monitor those while I'm talking. And when it comes to question time, you can also aggregate similar questions and so on. But please do make use of that. Okay. And Yancy, you're seeing my PowerPoint screen?
Yes.
Okay, and please, if that ever changes, just interrupt me and tell me I'm talking about things which are invisible. Okay.
Okay.
So I really like this idea of talking about disruptions to education. And of course, the last 2 years have been a severe disruption. I'm delighted with the fact that our Science Centre is teeming with children again. For 2 years, it was quiet, and it was just horrible because the children of South Africa need to be getting their hands onto science. But in some ways, COVID actually gave us an opportunity. And, I'm glad Yancy mentioned inclusivity, quintile 1, 2, and 3. One of the things, apart from many other problems in South Africa, is the digital divide makes all this e-learning a lot of nice talk, but for many schools, simply impossible to take part in. And it's really important that we consider them. At Unizulu Science Centre, we make sure that everything we do is available to everyone without exception, anyone who makes the effort to take part. So I want to tell you about what we called our co-video project, the video project which we did during COVID. So you heard a little bit about the Unizulu Science Centre. We're very proud of the fact that the Science Centre is 35 years old. We turned 36 in November this year. We're also proud of our relationship with the NSTF. And there you can see myself and my dear friend Alfred Sipper, who tragically passed away in 2017, holding our 2 NSTF awards that we won in 1999 and 2001. And we're very proud of the relationship we've had with the NSTF over the years. Just to put this in perspective, being 36 years old makes us older than 90% of the science centers in the world. So science centers are a very recent phenomenon. And for at least the last 25 years, we've been running matric workshops. Now, this is a typical matric workshop. This one is in Motu. And even though it's a tiny town in the middle of nowhere, we find when we arrive there that there are hundreds and sometimes even thousands of matric students who are desperate to get assistance with their matric, and in particular to take part in the experiments. You can see each of these pupils has a booklet on their lap. And we were running 4-hour face-to-face programs for over 25 years, myself and Alfred Sipper for most of the time. So this is the area we work in. We're based in Richards Bay, but these workshops went to 11 rural venues. These changed a bit over the years, but basically going to very remote areas of Zululand, and matrics would come together. Typically over a 2-week period, we would see about 10,000 matric science students. And in terms of KwaZulu-Natal's educational districts, there are 12 districts. This would cover 3 of the 12 districts. Now, of course, 2020 was lockdown. We were gearing up to run our matric workshops again. And we had this realization that, first of all, the matrics would need these workshops more than ever because, of course, they weren't getting input at school. But secondly, that we couldn't get to them and they couldn't get to us. So all school visits to the Science Centre were obviously banned. The country was locked down. And so we set about taking these workshops and making videos out of them. Many science centers around the world did this. So we took what was essentially a 4-hour face-to-face physics workshop. We had a physics and a chemistry. You can see this is one of our biggest venues when we were still face-to-face in Bizo Conference Centre in Mpangeni. And again, each pupil has a booklet. And in 4 hours, we took them through the essential skills to prepare for the exams. So we took that and made it initially into 8 one-hour videos, trying to highlight the essential skills. This was in 2020. Now, if you want to know a little bit more, we've called this program Essential Skills, and the best is to follow us on Facebook. If you just look up Essential Skills Matric on Facebook, it'll take you straight to our page. And that's the easiest way to get updates and contacts over there. So I'll refer you to that page. So what was the basis of this? The basis was that facts fade, experiments expire, but skills stick. Speaking a lot with examiners, with the people who are writing the diagnostic reports, what comes up time and time again is the fact that the pupils aren't too bad with content, but the skills are lacking. And of course, skills are essential, not just for matric, but for life. And South Africa desperately needs skilled matriculants, not just those who can cram their way through an exam. So that was the basis of these. So we're very proud of ourselves. In a few months, we got ourselves already, we made these 8 one-hour videos. I was assisted by the fact that I'd been running these workshops for 25 years. I had the material. I just made minor alterations to the booklet. We printed it. And then a friend sent me this cartoon, which really changed my life, because this realization, which of course I should have known having been here for so long, not all children have the same opportunity. And the fact is, some children are sitting comfortably inside with electricity and internet and dad's laptop, but most children are actually looking on through the window. Just the realization that the very children we wanted to help actually wouldn't have access to these videos. Now, I'm doing a little bit of research. Just about every school, no matter how rural, has a device, a laptop, a tablet, a television, or something like that. Almost none of them have internet that is good enough either to stream live or even to download. These videos are an 8 gigabyte download. So this digital divide is a real problem. And there's many reasons for this. I'd say in South Africa, we're looking at largely economic reasons, underdeveloped nations versus first world, poverty, lack of international investment, the fact that we're being held to ransom by our service providers. Our data is just about the most expensive in the world. Also geographical remote areas, and also the problem of approach, that people are fearful of technology. There can be cultural issues, and also just literacy skills, and so on. So what we decided to do is to physically distribute these videos. So we made memory sticks. We put really 8 hours of video and a lot of other resources on the memory sticks, and we physically distributed these to schools. We also initially printed 5,000 booklets to go to 180 high schools, to all the matric science learners in our local King Cetshwayo district. And we actually went out as far as we could with COVID, and we distributed these physically to the schools for them to use. I'm very proud of our relationship with the SAIP as well. And Eric Maluta also spoke about this, that when the SAIP heard about this, they'd got some funding from the Alan Gray Foundation, and they got behind the Essential Skills Project, and they actually helped us to print another 20,000 books and make another 1,000 memory sticks, which went out to another district, in Kanyagude district in KZN, but also went to 3 other provinces. And just to race up to the present time, this video project is now being used in all 9 provinces and has gone out to 80,000 pupils so far. We've printed over 4.5 million pages with support from SAIP and particularly from our local industry, South 32. So what's in these videos? Well, they start off with a little bit of theory, but they are not textbooks. And we have to stress to teachers that these videos are ideally used after a section has been completed. They're not meant to teach the section, they're meant to sharpen the skills. And when we do present theory, we hopefully do it in very innovative ways. So I'll talk a little bit later. There's some fantastic simulations available. Bez Sangari talked about this yesterday, and particularly from PHET, which just make it so much more interesting than just bullet points on PowerPoint. And one can use these in a very interactive way to compare. Here I'm actually using static friction to explain the work function with photoelectric effect. So use these comparing between different sections. The other thing is as many animations as possible. And if you know anything about the Doppler effect, you can see what's happening here. And just the understanding of how the pitch of the sound, the frequency of the sound changes according to the relative motion between the sound source and between the hearer. And I think there's a lot that you can do on a screen, and one can simulate and do experiments which can give a much richer understanding, so that when pupils get to this very confusing Doppler equation, they can see it in the light of the simulation and other videos, which hopefully has made it clearer. And with the theory, there's a lot of summaries. So this Doppler effect equation, again, if you teach it, it's very confusing because there's 4 different variations of it. But we take time to summarize these, lots of use of color and so on, to make it clear, instead of trying to learn off by heart, to make it clear from the context which equation should be used. Also animations like this, if you understand the threshold frequency from the photoelectric effect, it's a really great way to understand how different colors give different amounts of energy to the photoelectrons. Photoelectric effect, which has been taught normally in July or August for the matrics, very difficult to teach because it's very abstract. Just think it took Albert Einstein to unlock the photoelectric effect. That's what he got the Nobel Prize for in 1921. And then just to talk about some of the things which are often passed by, I wonder how many of us actually understand that the nature of the normal force is an electrostatic force. This great mystery the pupils have, you tell them that when the book pushes on the table pushes back. And I think most pupils imagine that there's some small men inside the table actually pushing back on the book. But in fact, it's simply electrostatic. It's simply layers of atoms being pushed closer to other layers. And with that, the electrostatic force increases and you get a reactive normal force, which is proportional to the weight that's pushing down. And again, wherever possible, to come up with strategies. So this is a strategy I've developed for problem solving. I call progress. So if you get one of those big 8-mark questions and you don't know where to start, well, you can go through this, draw a picture, check what is required, what is obvious, what is given, relate these with an equation, substitute, and solve. And apart from helping you to make a start, really helps you to get part marks along the way. Again, when we look at motion graphs, these are literally the only 9 graphs you need to know when you're at school. And by summarizing them on a page, it really helps to compare the graphs for 0 acceleration at the top, positive acceleration in the middle, and negative acceleration at the bottom. Now, unfortunately, today I'm just talking, but in the videos, we spend a lot of time with simulations. We use Pasco motion sensors, do lots of experiments to make these graphs actually come alive, and then apply them to the exams.
Derick.
Hello.
Morning. My name is Jock. I'm a representative of SAI, which is the Industrial Engineering Institute. And I just wanted to quickly comment and just say that I think that idea of progress is actually really, really cool. And it's probably something that I'm going to use in my everyday life as well, problem solving as an engineer. So yeah, thanks for that one.
Fantastic.
That's one of the things that I learned today. That's it.
Okay. I even think it'll help in an argument with the wife. So go for it. Okay. So thanks, Jacques. And again, you know, when I'm finished today, I will gladly send to anyone who contacts me, I will send you these resources free of charge because of the sponsorship from SAIP and South 32. So if I'm rushing past things, don't worry, there'll be a way to catch up with them. Okay, so, and yes, you can do experiments online and through Zoom. And for example, this is Data Studio. It's a fantastic oscilloscope that Pasco Scientific makes. Again, it's just not possible for me to do all these live, but it shows you the shapes of sound waves and lets you do fantastic experiments, which I do in the videos. I mentioned the motion sensor. As one walks in front of the sensor, it draws motion graphs in real time. And there's a fantastic competition called Match Graph, where a graph is pre-drawn and you have to try to walk and it gives you a score in the bottom corner. All of this is done in the videos. The syllabus experiments are done. So here is the experiment for internal resistance. We set up the actual experiment. We do the experiment, but we feed the voltage and current directly into Pasco's capstone so that the table is drawn, the values are there, the graph is drawn, all in real time. But the pupils are left to record the data and draw their own graphs in their booklet. So they are fully involved in the experiment in every way except touching the apparatus. I'd love them to touch the apparatus, but this way 80,000 pupils have been able to do this experiment. Then simulations. And again, I'm going to talk quite a lot about PHET because we have a very strong relationship with them. But these simulations are absolutely fantastic. And I think I'm just going to quickly see if I can change my screen. So Yancy, if you can just confirm that you now have a screen with the light shining and electrons moving and so on.
Yes.
Okay, excellent. Thank you. Just one never knows quite which screen is showing. So photoelectric effect. PAGT has this fantastic simulation. Here's the graph which pupils have to work with, electron energy versus light frequency. So I can turn the light up to 100%, it's shining on a sodium metal over here with a certain work function. That dot shows the relationship between the current frequency of the light and the electron energy, which is 0 at the moment because nothing's happening. And with the slider, I can increase the frequency, changing the color, going through red, yellow, green, light blue, dark blue. And now you can see we've reached the threshold frequency. So some photoelectrons are being knocked out of the screen. And as I increase that, you can see the line goes up there to show that the maximum kinetic energy of those photoelectrons is increasing. And you can see really nicely how that graph is formed. This is a very difficult experiment to do live. You need very fancy equipment, but this simulation is absolutely fantastic. And then to compare work functions, I can change my metal from sodium, which has a low work function, to, for example, platinum. You can see here, as I increase the frequency, watch the blue dot on the graph. We have to get deep into the ultraviolet before we reach the threshold frequency, which is much higher for platinum, which is why it's not a good source for solar panels, apart from being really expensive. And now you can see, isn't that great? It's the same graph with the same slope. The slope is h, Planck's constant, but you can see the threshold frequency, 1.5 times 10 to 15 hertz, is double what it was before. And there's so many experiments that you can actually do with this. That's just one of about 200 simulations which are freely available on the internet. What we did, though, is we downloaded all these simulations onto the memory stick so that the teachers have them without ever needing to go onto the internet. And Yancy, if you can just confirm that we've changed to a straight line graph here.
Yes,
Thank
I
you.
see it.
Sorry to keep asking, but sometimes one doesn't know what one's showing. Okay,
No
here's
problem.
another simulation which allows you to explore straight line graphs. This is taught in grade 9. But the examiner's comment about the matric exam is that the main problem pupils have with the graph questions is not the content, not the internal resistance or photoelectric effect, but calculating gradient and intercept, which they should have learned in grade 9. So one does need to go back. Here's a fantastic simulation for projectile motion. Even though two-dimensional projectile motion is not in the syllabus, one can ask lots of questions with free body diagrams and so on based on this, and you can get to shoot a grand piano out of a cannon, which is great fun. This is one of my favorites. It's called the moving man, and you can move this man around or give him various velocities and so on, and graphs will be drawn in real time, comparing position, velocity, and acceleration. These are fantastic tools, and they can be used just as effectively online as live in a classroom, and all of these tools are put in the memory stick for the teachers. Then, Yancy, when you were summarizing yesterday, you talked about the importance of including real-life context. One of the things that saddens me is grade 12 pupils are technically at their intellectual height, aren't they? And yet they spend most of the year on boring revision, which really is a tragedy. You know, this is the year they should really be taking wings and flying. So although essential skills is aimed squarely at the matric exam, because that is important. I've had 2 daughters who've recently matriculated. I know how important the matric exam is, but we do take time to talk about applications. So for example, all these graphs we're doing, is it only useful at school? No. If I just look at various screens from my cell phone, you can see that there are graphs all the time. Here's one for my data usage. Here's one for how many steps I've walked. Here's one for how far I've cycled. And here's breaking down the different legs of my cycling. And before any of you see how slowly I actually walk and cycle, I will move on. But you can see the importance. We encounter graphs in everyday life all the time, and it's an essential skill for life, not just for science. Talking about the photoelectric effect without mentioning solar panels is really crazy, because South Africa so desperately needs solution to electricity problems. We have so much sun. Overseas, they've set up solar farms. This is a solar racer. It went right around South Africa, 5,000 kilometers, an average speed of 80 kilometers per hour without any energy input except from the sun. Isn't that amazing? Here is NASA's solar-powered aeroplane, which in theory can fly right around the world without stopping as long as it flies west. As long as there's sunlight, it can stay aloft. So some fantastic examples. And of course, the International Space Station, 350 kilometers above the Earth, traveling at 30,000 kilometers per hour. An extension cord is not possible. How does it get power for the 3 astronauts on board? Through an extensive array of solar panels. I think it's a tragedy if any matric student has never seen this picture, but they know how to manipulate the equations of the photoelectric effect. Because, as Yancy said, the real life contexts are absolutely vital, and they take that theory and they actually make it come real. And I do lots of experiments with solar panels, with online voltmeters and so on. As I say, I just don't have time to show you that the current set is 16 hours of video, but Yancy wouldn't give me 16 hours to talk, so I'm going to have to squeeze things. And then
Sorry,
a personal application.
negotiate.
Sorry?
Sorry, Derick, we can negotiate about more airtime.
No problem. But the 16 hours of me talking is very useful if you struggle to sleep at night. Okay. And a personal example, you know, we teach free body diagrams, and these are classic pictures of the 4 forces acting on an aeroplane. Well, for my last birthday, my wife bought me an experience which started off with 2 hours of flight instruction. Look at this picture. The instruction was on Zoom because of COVID, but it's exactly the same picture. We got taught the free body diagrams, and then I got to use them in that I got to fly an aeroplane. And first time up, I took off, flew, and landed. And I want to tell you, when you've done that, you really understand the free body diagram for an aeroplane. And it's so important to have these. Now, of course, exams are important. And we have very carefully analyzed the last 3 exam papers, 2018, 19, and 20. We're busy adding the 21 and looking question by question. Question 2 is always Newton's laws. So one can look from year to year and look at the specific skills which are needed and how one can compare. Now notice, I don't try to show pupils how to answer this question, because this question will never come up again. I show pupils how to answer this type of question, because once you've learned that skill will be with you for always. And just to be able to look and say, right, what graph skills do you need? Well, you need to analyze and explain trends in a sketch graph, read values, but also to draw graphs. And we look at examples of each, both in the booklet and also in the videos. The other thing is, here's a typical example, typical circuit where you have to analyze and give current and power and so on. We do the theory with the equations, get the answers, but we also use this fantastic PHET circuit builder to build a circuit which is an exact copy of the exam circuit. The PHET circuit is live, and then we can pull in voltmeters and ammeters, measure currents and voltages, and show in reality, well, in simulation, that the answers we get in the exam are actually real. So it's not just grinding through the answers. You don't need me for that. A memo will suffice. Now, again, the real life context. I think it's so important for the stories of science to be told. And Yancy, I guess that's what you're doing over these 2 days. And at the end of each video is an interview with someone who's active in the field. So starting with Brian Massara, the CEO of the SAASTEC. Becky Masakane is now one of the supervisors at South 32, our main sponsor. But in 1994, as a matriculant, he attended my very first matric workshop. And he reflects just in 5 minutes about how helpful these workshops have been. Mamansa Diale is the head of solar energy research in South Africa. Mongezi Sotsaka handles the incredible 10,000 volt, 230,000 amp system that runs South 32, and he talks about that, and so on and so on. The other thing is, we also talk about matric, and you know, it really bothers me that we've told our pupils that 30% is enough, because you know, they're teenagers. I've had teenagers, if you tell them 30% is enough, they will aim for 30%. So I really push the pupils hard to aim a little bit higher. I mean, just think, if you were lying in the dentist chair, would you find it reassuring for the dentist to tell you, don't worry, I passed dentistry with 32%? Or if you went to visit the cockpit on your flight from Durban to Cape Town, and you heard the pilots discussing, don't worry, I got my pilot's license with 34%. We're very good at flying. We've never successfully landed yet. Now, obviously, these are ridiculous examples, but we should never tell our pupils that 30% is enough. It's not. I have a visiting American professor at the moment who says in American schools, pass mark is 60%, and we need to set our sights a little bit higher. So how was this whole program implemented? Well, starting with the concepts, the content, the skills, the exams, feeding them into the booklet, using that to make these PowerPoints, and then to record the videos. To record the videos, I did exactly what I'm doing now. I had a Zoom conversation with myself, shared screens, and recorded it. And you end up with video, which is actually very good quality, but very small file size, 2 megabytes per minute, whereas a standard cell phone video is 100 megabytes per minute. And these things are important when data is an issue. And again, I want to commend the Institute of Physics, who assisted with editing, printing, distribution, support monitoring, and evaluation. And what we try to do as well is to take a look in physics, what physics is being taught in which month in grade 10, grade 11, and grade 12, and then encourage the teachers not just to try to plow through 16 hours of videos, but to use the appropriate video at the appropriate time. So 2021, after using it for 1 year, we had another year of lockdown, but I actually added 50% more content, because having had a chance to evaluate, we saw that what we'd done in 2020 was useful, but actually not enough. And we've now committed ourselves as a science center to the big 5. We're in Zululand, we have the big 5 here. We've finished physics. We've also finished a series on essential skills for life science, not done by me, because I gladly dropped life science in grade 9. But my colleague Deloshni Chetty has done a fantastic series of videos on life science with booklets, which are also available. We are working on chemistry, and I mentioned a visiting American maths professor who's assisting me at the moment to do a series on Maths 1 and Maths 2, algebra and geometry. So what are the advantages of actually doing this on video instead of live? I want to say I really miss seeing pupils face-to-face, so I'm delighted that they are back in our science center. But whereas I could influence 3 districts in KZN, learners all over South Africa are now benefiting. There can be small learner groups, and particularly when COVID was more of a problem, this was a big issue. We just couldn't get 1,000 learners together like we used to. The sessions can be short. When we got lots of learners together, we had to do 4 hours because we only had 1 chance, and that really is too long for people to pay attention. Workshops take place in school. There's no time out of school or disruption or COVID, and so on. For myself, I present once only. There's no exhaustion. Traveling around for 2 weeks, covering 1,000 kilometers, seeing 10,000 pupils. I started doing those workshops in my 20s. I'm now almost 60, and one gets tired. And the experiments always work when they're on a video. But then one might say, what's this craziness about distributing memory sticks? Why don't you just make it available over the internet? Now, I went to a conference recently about e-learning, and Avashni Munsami had done a survey about challenges faced with online learning, and it's not rocket science. The 2 are lack of network and connectivity and high data costs. Those are the 2 main challenges for most South Africans. And again, Yancy mentioned quintile 1, 2, and 3 schools. None of our Zululand schools in those quintiles would be able to connect to this NSTF workshop. They just don't have stable enough internet to stream, and an 8 gigabyte download would actually cost them more in terms of data than the 80 Rand I pay for the 32 gigabyte memory stick, which I give them, and which is covered by a sponsor. So the advantages of having offline videos rather than streaming: first of all, there's no connectivity issues. In fact, even if you have load shedding, as long as your laptop is charged, you've got all the videos with you. You can play them whenever you want. Secondly, there's no ongoing data costs because you have everything. And thirdly, there's no scheduling issues. All of you have to listen to me right now, because in an hour's time, I won't be talking. But for teachers, it's so much easier to be able to start and stop when you want. So in a sense, it's like having Netflix instead of DSTV. You can choose when you want to start. There's no need to schedule. And importantly, teachers are encouraged to pause the video and say, give the pupils 5 minutes to try this problem before proceeding. Teachers can pause the video to explain in isiZulu, or just to replay a section which we didn't get. So of course there are disadvantages. I miss the personal contact. Virtual is never as good as face-to-face. One can look at cost of making videos, but again, I basically made them for nothing just by using Zoom. And I don't believe we need flashy, fancy, very expensive videos. We approached the SABC about making these videos. They told us it would cost 10,000 Rand per minute. I've made 16 hours of video. It's just completely impossible. So the cost of memory sticks and physical distribution, it really isn't much compared with data. And of course, materials can become out of date, but one can easily use the internet to upgrade materials, and that would only be a small download. Of course, teachers may not use the materials, but that is true of any material. So these materials are available online through various different portals. I will also put my email in the chat, and maybe Vilna, if you could also just pop my email in the chat, thefish@iafrica.com, and please feel free to contact me. But I want to talk to you about this particular portal here, which is called Ineti. Just before I do, just picking up from yesterday, Andrew Patterson mentioned making smartphones more accessible by zero-rating smartphones and providing subsidized Wi-Fi. That would be fantastic, but in Zululand, we're still a long way off from there. Bez Sangari talked about the importance of asynchronous online courses as well as synchronous. And I want to tell you the scheduling issue is a big issue for us here. So I just want to close by mentioning a couple of other projects and making the point very strongly that digital does not have to be online, because there's this assumption that digital resources have to be online. They don't. And for most people in South Africa, getting online is actually quite a big problem. So let me mention two other projects that are using my videos in fantastic, innovative ways. Now, Dr. David Johnson really wanted to be here to talk about Ineti this morning. He wasn't able to, so let me talk briefly about Ineti. This is a fantastic project taking place in Ocean View in Cape Town, and it's a community-owned network. What they've done is they've centered it at Ocean View High School, but they've put up various wireless repeaters around the community. So practically the whole township of Ocean View of 10,000 people have got access to this wireless LAN. They've got access to resources without ever going onto the internet. There's no internet involved. It's a wireless network based at the school. So this is so here's Dr. David Johnson, and here's the community who've done all the work putting things up and putting up the repeaters at practically quite a low cost. So this network connects you to the splash page. All of these materials are on a server at Ocean View High School. So instead of pupils using it to watch TikTok videos, they can't. But every grade at Ocean View High School has got a folder. Now, we know that most private schools in South Africa through COVID simply made all the materials available online. But this is not realistic for most of our pupils. So these pupils can access any of their materials without ever going on the internet, super high speed, 100 megabits per second, zero data costs. The whole of Wikipedia is downloaded onto the server. All the Khan Academy talks and all of my videos are also available here. What a fantastic project. And I want to tell you that this project won first prize for the Connecting the Unconnected Challenge for the International Institute of Electronic Engineering. So first prize worldwide. I encourage you to find out more about Ineti. One other example, which was actually done by my nephew at the University of Cape Town. So he runs a program called Golden Futures. And before lockdown, more privileged students at UCT would invite township students from Cape Town to come in and receive face-to-face tutoring, particularly in maths and science. But the challenge of lockdown was they couldn't get together, so they wanted to do it online. But again, what was the biggest challenge? Data and connectivity. So they set up a WhatsApp-based system because WhatsApp is affordable, it's familiar, you can do multimedia tutoring, and it's preferred by students. And there's very little data involved in WhatsApp messages. And my nephew set up a program which would receive the messages, would look for keywords like grade 10 biology, and then would send them to the appropriate tutor who would get into conversation through voice notes, through WhatsApps like this. But one addition to this was if someone asks about internal resistance, for example, what they can do is send one of my videos. And I've deliberately made my videos, the individual videos, less than 5 minutes and less than 16 megabytes, which is the WhatsApp threshold, so that the tutor can send a video, let the pupil watch it on his phone, go through the bits, and then come back and say, we can discuss it once you've seen the video. So digital does not have to be online. And with our video project on memory sticks, with Ineti, with the wireless LAN, and with Golden Futures using WhatsApp, they're all examples of actually distributing really good digital materials without needing internet dependence. One last thing I want to say, and I haven't really been a good model of this, please beware of death by PowerPoint. And just because it's PowerPoint doesn't mean it's any better than actually just writing on the board. And there's so many resources we can use, so many simulations, online experiments, and so on, which can make our lessons so much more interesting. So please remember, guns don't kill people, bullet points do. Thank you.